Now that we've talked about the derivative, let's talk about a couple other definitions that come right after this. So, one thing we have is different notations for the derivative. There's a few different ones that are somewhat common, but let me just write out a few that we'll talk about here. All right, so let's say we have a function y equals f of x. There's a couple ways we can write down this derivative. Right? One way we write down is f prime of x. Of course, that's what we just talked about. All right. Remember how the derivative was kind of it was exactly the limit as delta x goes to 0 of delta y over delta x? That's a definition of the derivative. Well, following that notation here, we also call this dy dx. Right? That's another way we'll often write the derivative. Another way we can write this is what's called the so-called Leibniz notation, which is this here already. But another way we could write this, the derivative, we think of it as an operator, something that we apply to a function. So following that kind of idea there, we'll write d dx of f of x. Right? Something that's pretty common is to put some extra parentheses around this or some brackets around it. There's a few ways you could do that. All right. Another thing we could do is, like, let's say we want to compute, f prime of 3 or something, right? Let's say it's something like that. How would we signify that with this kind of notation? Right, with this Leibniz notation here, this fraction notation. Well, sometimes you'll just see this, right? Dy dx of 3. That's something you'll see. Another thing you'll see is dy dx, and then what we do is we draw this vertical bar here, and we would write x equals 3, or whatever the independent variable is, right? And this line here, this reads as evaluated at, right? So again, this is f prime of 3, or dy dx of 3, or dy dx evaluated at x equals 3. These are some common notations when you actually want to plug a number into the derivative. Otherwise, these first two here are basically what you're going to see most of the time. Usually, if you see this one, it's applied to a specific function. Something like, d dx of cosine x, for example. You might see this notation used when it's something like this. All right? Another part of this notation I want to talk about here, and this is really why this kind of notation right here is important, these two. If we have the derivative, right, we now know that this is a function of x, right? So, actually, let me do this. This is a function of x. Let me move this back over a little bit. Right? So, since it's a function of, this is f prime of x, since that's just another function, we can take the derivative again. Right? We can just take the derivative again. Okay? So, what does that give us? Well, this one, we usually will write d squared y by dx squared. All right, notice that the squared moves over because the bottom, we don't write these parentheses, but the bottom is thought of like this. All right, because the object down there is dx, not d times x. Right, it's an object that's called dx. All right, on this side, another notation one of these days I'm going to stop doing this. Okay. Another notation for this is f prime prime of x. All right, so what do you think this is? Well, we took a derivative of a derivative, so this makes sense to call this a second derivative. Right? The second derivative also actually conveys really useful information about the function, and it has really important applications. This one here, we'll read this as d squared y dx squared. This one over here, instead of saying f prime prime, I mean, you can, there's nothing wrong with that. But we normally say f double prime. Right? And this is the second derivative of f. Okay? So then, it's probably no surprise to you at this point that we could do a third derivative. Right? By just taking an additional derivative here. So if we do, say, d dx applied to d squared y dx squared, this gives us d cubed y dx cubed, or what we'll call f triple prime of x. Right, and this is a third derivative. Of f. Right? And why stop there, right? So the reason I want to do one more here is because our notation here in this notation changes just a little bit. Right? You could keep doing primes, but at some point it's going to get pretty ridiculous, right? You're going to have like primes that stretch all the way across the page if you had like the 20th derivative. So what do? Well, the fourth derivative we would write like this. Okay? Or in the prime notation and the I guess we can call it function notation here. What we would write is, you could use Roman numerals. I've seen this before. Usually what you'll see though is we'll write a 4 up here, but we're going to put that 4 in some parentheses. All right? This here is the fourth derivative. Of f. Right? And then at this point, this notation doesn't really change anymore. Right? These 4s here, they just keep going up as we get higher and higher derivatives. This 4 inside the parentheses just keeps going up, to a 5 for the 5th derivative, to a 10 for the 10th derivative, and so on. All right? So hopefully that makes sense, gives you a nice introduction to some of the notation here. And we'll look at some applications coming up.